Hello guys, my name is Bino, and in this video we'll be determining the extreme values of the function f, which is equal to x plus y plus z, subject to the following constraints: x squared plus y squared is equal to 4, x plus z is equal to 1. We are given the function f of x, y, z, which is equal to x plus y plus z, and the constraints x squared plus y squared, which is equal to 4, and we are also given x plus z, which is equal to 1. We name the first constraint the function g of x, y, z, and the second constraint we name it h of x, y, z. We use the gradient method in order for us to determine the extreme values where delta f is equals to lambda multiplied by delta g plus micro multiplied by delta h. Delta f will be defined as the partial derivative of f with respect to x, and the partial derivative of f with respect to y, partial derivative of f with respect to z, and delta g will be equal to the partial derivative of g with respect to x, and the partial derivative of g with respect to y, partial derivative of g with respect to z. Delta h will be equal to the partial derivative of h with respect to x, partial derivative of h with respect to y, partial derivative of h with respect to z. In this formula, we are going to substitute these three formulas, where f subscript x, f subscript y, f subscript z will be equals to lambda multiplied by g subscript x, g subscript y, g subscript z plus micro multiplied by h subscript x, h subscript y, h subscript z. We determine delta f by differentiating f. The partial derivative of f with respect to x, the derivative of the y plus z will be equals to 0, and the derivative of the x will be equals to 1. And the partial derivative of the f with respect to y, the derivative of the x plus z will be equals to 0, and the derivative of the y will be equals to 1. And the partial derivative of f with respect to z, the derivative of the x plus y will be equals to 0, and the derivative of the z will be equals to 1. We now determine the delta g. The partial derivative of the g with respect to x, the derivative of the y squared will be equals to 0, and the derivative of the x squared will be equals to 2x. And the partial derivative of g with respect to y, the derivative of the x squared will be equals to 0, and the derivative of the y squared will be equals to 2y. The partial derivative of the g with respect to z, the derivative of the x squared plus y squared will be equals to 0. On the other side, delta h will be equals to the partial derivative of the h with respect to x, the derivative of the z will be equals to 0, and the derivative of the x will be equals to 1. The partial derivative of h with respect to y, the derivative of the x plus z will be equals to 0. And for the partial derivative of h with respect to z, the derivative of the x will be equals to 0 and the derivative of the z will be equals to 1. From here we extract the component equations from that equation. We start with the x component. F subscript x will be equals to lambda multiplied by g subscript x plus micro multiplied by h subscript x. For the y component, we have f subscript y, which is equals to lambda multiplied by g subscript y plus micro multiplied by h subscript y. And for the z component, we have f subscript z, which is equals to lambda multiplied by g subscript z plus micro multiplied by h subscript z. From here, we substitute the gradients inside the formula. We start with the f gradients. The 1, 1, 1 will be equals to the lambda, and the g gradients, we have 2x, the 2y, and the 0 plus micro, and the h gradients, we have 1, 0, and 1. We also substitute inside the component equations, and we start with the x component. We'll substitute the 1, the 2x, and the 1. So we get 1 will be equals to lambda multiplied by the 2x plus micro multiplied by 1. And inside the y component, we have the 1, the 2y, and the 0. So this will be 1 will be equals to lambda multiplied by the 2y plus micro multiplied by 0. And inside the z component, we'll substitute the 1, the 0, and the 1. 1 will be equals to lambda multiplied by 0 plus the micro multiplied by 1. Finally, we have our three equations. 1 will be equals to lambda multiplied by 2x plus micro. 1 is equals to lambda multiplied by the 2y. The micro multiplied by 0 will be 0. And we have 1 will be equals to the micro. We also have the two equations of the constraints which we have to utilize. The x squared plus y squared is equals to 4. X plus z is equals to 1. Let's start with the x plus z equation, which is equals to 1. And the x squared plus y squared is equals to 4. We can see that the micro is equals to 1. So in the place of micro, we substitute 1 in the first equation. So we have 1 will be equals to lambda multiplied by 2x plus 1. We take the 1 from the right to the left. 1 minus 1 will be equals to lambda multiplied by 2x. 0 is equals to lambda multiplied by 2x. For 0 to be equals to lambda multiplied by 2x, either the lambda is equals to 0 or the x is equals to 0. If lambda is equals to 0 and we substitute 0 for lambda in that second equation, 0 multiplied by 2y will be equals to 0, and we'll have a contradiction where 1 will be equals to 0. So the lambda is equals to 0 will not be a solution. Instead, x is equals to 0 will be the correct solution. We substitute 0 into the x plus z equation. 0 plus z will be equals to 1, and z will be equals to 1. We also substitute x where there is 0 in the x squared plus y squared equation. We get 0 plus y squared will be equals to 4. So y will be equals to plus or minus the square root of 4, which is equals to 2. So y is equals to plus or minus 2. The z is equals to 1, and the x is equals to 0. We now have the coordinates where the extreme values occur. From here, we just determine the extreme values. We have the 0, the positive 2, and the z, which is equals to 1. We have the 0 again, and the negative part of the y, and the positive 1 from the z. We substitute this into the f of x, y, z equation. The f of x, y, z was given as x plus y plus z. So our f of 0, 2, and 1 will be equals to, where there is x, we substitute 0, where there is y, we substitute 2, and where there is z, we substitute the positive 1. So the extreme value will be equals to 3, and for the other part, the 0, the negative 2, and the 1, we substitute 0 for x, and the negative 2 for y, and the positive 1 for z. And this extreme value will be equals to negative 2 plus 1, which is equals to negative 1. Since the 3 is greater than negative 1, the 3 will represent our maximum value, and the negative 1 will be our minimum.